Okay, here's a couple of diagrams of those phylogenetic trees showing you common ancestors. And we can see on this top diagram the most recent common ancestor for A, B, C, D, and E versus the most recent common ancestor between A and B. So again, the closer they are on the tree, the closer they are in relation. The same diagram at the bottom, except for looking like brackets, this is a pretty common way um, to represent this information. It still shows you the points coming together, so you can see, like with A and B, that show the common ancestor. They're just tipped on their side. Number 23, which characteristic used by the researchers would not be helpful in distinguishing the collected organisms from bacteria? So I highlighted not, because it's one of those things we have to be oh so careful about. Are we looking for something that's true, or are we looking for something that's false? So we're looking for something here that's not going to be helpful. So if we're trying to distinguish it between bacteria, if it's multicellular, that would be helpful because bacteria are unicellular. So A's out. The presence of chloroplasts. Well, bacteria don't have chloroplasts, so that would be helpful. So B's out. The presence of a cell wall. Well, bacteria have a cell wall, so that won't be helpful. And then having cilia. Bacteria don't have cilia. Those are the tiny hair-like projections. They might have flagella to help them move around, but not the cilia. So the answer is D. Number 24. Which modification to figure 1 correctly represents the information showing only the domains? So let me take you back to figure 1. And here are the kingdoms. Bacteria, archaea, protista, plantae, fungi, and animalia. What we're looking at is how would we combine this just to show the domains? So the 3 domains are bacteria, archaea, and then eukarya. So let me get back to this question again. 4 days later. Here it is. So bacteria on the left, and then giving rise to the archaea, and archaea being on the same branch as the eukarya. So the answer is C. So we really didn't need to have a lot of background knowledge here, except for knowing that the 3 domains are the eukarya, and then the 2 of bacteria and the archaea. Number 25, which statement about kingdoms is best supported by figure 1? So again, this is one of those we're just looking at. It's all you got to do. Kingdom 1 is an ancestor of Kingdom Protista. Kingdom Protista is more specialized than Kingdom Plantae. Kingdom Plantae is more diverse than Kingdom Animalia, or Kingdom Animalia is most closely related to Kingdom Fungi. So again, we've seen this in a different version, but Kingdom Animalia is closer in relation to Kingdom Fungi because of their position. So if we look at the other things, I can't see specialization, I can't see diversity, and on that, I didn't see that there was that type of ancestry. So with those types of questions, we're just sticking to the facts. Okay, number 26. Which characteristics will help the researcher determine if an organism was in kingdom Plantae or Protista? So you can use table 1 or not. So if I'm talking about Plantae or Protista, plants definitely have a cell wall. Plant cell walls are made of cellulose. Plants can do photosynthesis, some protists can, and then plants have specialized tissues. So let's go to this table 1. Hold on, I forgot the question. Gosh. So which characteristics will help the researcher determine if an organism was in the kingdom Protista or Plantae. I'm thinking we're going to have to go with having specialized tissues because Protista are single-cell organisms, and single-cell organisms cannot have tissues. I've added this diagram here of comparing the 6 kingdoms because that's been a common type of question on the SOL. This shows you the 2 kingdoms of prokaryotes and the 4 kingdoms of eukaryotes. It talks about their body form, multicellular, their mitochondria, so that tells us how they make their energy, if they have a cell wall. Again, nutrition kind of goes along with mitochondria, how you make your energy. Whoopsie. And then whether or not they can move. Use the information in the table to categorize the organisms in their appropriate kingdoms. So we've got Plantae, Animalia, fungi, and Protista. All right, so give me 1 second. Got 2 different devices going on here. Okay, so I'm using the information in the table to categorize the organisms as a plant. So if I'm looking at a plant, yes, it's multicellular. Yes, it has chloroplast. No, it doesn't have cilia. Yes, it has a cell wall, and no, it doesn't have chitin. So that tells me that the plant is organism Y. Okay, on to the animal. Multicellular, yes. Chloroplast, no. Cilia, no. Cell wall, no. Structural chitin, yes. Not us, but some animals have chitin in their shells. So it means that animals are organism W. There's 2 fungi. Multicellular, well, yeah, some of them are multicellular. Chloroplast, no. Cilia, no. Cell wall, yes. Made of chitin, yes. So that means that one of the fungi is V. Sorry, it's V. Okay, let's see what's our other one. Let's see, here's a multicellular, no. Chloroplast, yes. That's not what we're looking for. Okay, fungi, multicellular, no. Chloroplast, no. Cilia, no. Cell wall, yes. And chitin, yes. So that means that Z is also a fungus, a unicellular fungus. And last but not least, the Protista. The multicellular, no. They have chloroplast. Well, yes, some of them do. Cilia, yes, some of them do. Cell wall, yes, some of them do. And chitin, no. So that means the protists are X. Okay, categorize the organisms into their most likely ecological roles. So again, I'm kind of flipping back and forth. So we're going to look at autotrophs versus heterotrophs. So we'll start with auto. So we know what autotrophs have to have. They have to have chloroplast. So that means that organism X and organism Y are able to do photosynthesis. And if I'm talking about heterotrophs, these are my organisms that don't have chloroplast. And they don't do photosynthesis. So that could be Y and W and what was the other one? Z. Sorry, I have to go back to the question every time. And then I have here just a comparison of different organisms for autotroph, heterotroph. Okay, we'll come back to these. They're a different set of questions.